All right, guys. Now we have all our pieces: absolute value inequalities, absolute value equations, linear inequalities, and now we're going to put it kind of all together. We're going to do systems of linear inequalities. You know how to do systems of equations, and your solution was where the lines intersected. Now we got systems of linear inequalities, and we'll talk about what that solution looks like in just a minute. So, first step
is graph the first inequality.
So we're going to start with that blue one. 1/3 y is less than or equal to 1/3 x plus 4. So we go up 4, and then slope of 1/3, so up 1, right 3, up 1, right 3. I'm going to go all the way across the graph again to guarantee that I have an accurate image. And it's less than or equal to, so it's a solid line.
Reminder that this is probably where we need to use a ruler and make sure that our lines are absolutely straight.
Yep. I'm freehanding it, but only because I'm on the smartboard and finding a ruler is kind of hard to do. Now, I look here and I see that it says less than. So my step 2
is choose a point to determine shading.
So like we did before, I'm going to choose 0, 0. If I put 0, 0 in here, I get 0 less than or equal to 1/3 x times 0, which is 0, so 4. That is true. So what I'm going to do for right now is I'm just going to mark that I'm going to shade down. And there's a reason for that, so just go with me on this.
So then we got to take a look at step 3. It says graph the second inequality.
I'm going to graph that in red. We've got negative 5/3 x plus 10. So I'm going to go up to 10. And then negative 5/3, so down 5, forward 3. Yep, I have a point of intersection, but that's not my solution. Down 5, forward 3. And I see that it is less than, so I'm going to use a dotted line. And then I'm going to use my step 4.
Which says, choose a point to determine shading.
So now, I know that my shading is going to be less than, so when I choose 0, 0, I end up with 0 less than negative 5/3 times 0, 0 plus 10 is 10. 0 is in fact less than 10, so that means that I'm going to shade this way. But then here's our catch. I'm going to scroll down and then I'll scroll back up here again.
So step 5 says, where shading overlaps is the solution set.
So when we look here, if I shade below my blue line, and I'm going to show you on this one with multiple shading colors just so you can see. If I shade below the blue line, that is going to be all this down here. Now, if I shade on the other one is going to be right here. And so where our overlap is where our solution is. And our overlap is going to be below the blue line to the left of the red line, which I'm going to shade in my nice dark purple. You can probably see some of the green that was formed from the yellow and blue because yellow and blue make green. Of course, you guys won't remember that Ziploc commercial. And now we got this funky shaded region. Now, the reason why I drew the arrows is because if you can see that you're below the blue line, so once you draw your red line, you're either going to be to the right or to the left of it, below that blue line, then you can figure out where your shading is and only shade once instead of shading multiple times. Especially when you get to something like B. Because now, we got 4 inequalities. So we follow our same process, except now we're going to basically repeat steps 1 and 2 4 times. So our first one, y is greater than negative 2x plus 5. So we go up 5, and then negative 2x, so down 1, down 2, right 1. We're going to continue that process all the way down to the bottom of my graph and all the way up to the top of my graph. And it is strictly greater than, so it is a dashed line. And it is less than, we're going to choose 0, 0. And 0, 0 gives me 0 greater than 5, which is not true. So that means I'm going to shade basically to the right and above the blue line. Then I've got y less than or equal to 3x plus 1. So we go up 1, and then we got a slope of positive 3. So we go up 3, right 1, up 3, right 1, up 3, right 1. And I'm going to just finish because I need to have a line that's accurate. And this one is a solid line because it is less than or equal to . And then we put in 0, 0, we get 0 less than or equal to 1. So that means that I'm going to shade this way on this one. And then x greater or equal to 0, well, that's my y-axis because it will cross, the y-axis crosses the x-axis at 0. And it said it's greater, so I'm going to shade this way. And then y greater than or equal to 0, well, that's the x-axis because that crosses the y-axis, which basically says when it's greater than or equal to, by going to the left or the right of the y-axis and above the x-axis, that locks us into the first quadrant right here. And so we have to go above the blue. So I'm going to make some dots with my highlighter here. Above the blue is over here. Below the red is going to be here. And so what our solution ends up being is this region right here. So it's a matter of getting the feel for it, and what might help is to mark your shading with a pencil and then shade your final region with a highlighter, and I will have highlighters provided for you. So, now that you've seen that, now we look at graphing when there's only one variable. So I see x alone. Remember, when I see x alone, the first thing I should think of is vertical lines. And so I've got, think of this, if I graphed it on a number line, I'd be at -2, and I'd be at +6, and they'd be filled in circles, and so ours are going to be solid lines. Oops, and of course I have a dashed line when I say that. So let's try that again. We have a solid line. And we have another solid line. And x in the inequality is in between -2 and 6. So when we highlight, we are going to be in between -2 and 6. Likewise, now we've got -3 is less than y, which is less than or equal to 5. So when we go to graph, we've got y, so that tells me my lines are horizontal. So I've got -3, and I've got +5. +5 is going to be a solid line because it is less than or equal. And because it is -3 is strictly less than y, we're going to make a dotted line here. And once again, y is in between -3 and 5, which means I'm going to shade in between -3 and 5. Our final piece to today, I know, take a look at it, freak out now.
Take a breath.
Let's go ahead and read this. Now I will give the disclaimer, this used to be a you try problem, so be grateful that it's not. We have an expedition, which is a group of people. They are 240 miles away from their base camp, and they just found out a storm is predicted to reach the area of their base camp in 48 hours. The expedition needs to travel by boat and then walk the remaining distance to camp before the storm hits. The explorers can navigate the boat at a rate of 12 miles per hour or walk at a rate of 3 miles per hour. We want to let X represent the number of hours traveled on foot and Y represent the number of hours traveled by boat. We want to write a system of inequalities that can be used to determine how long the explorers may travel by foot or boat to reach the base camp before the storm. Now, note, it says We are going to write the system of inequalities. We are not going to solve, we're just writing. So if you think about it, X and Y both represent number of hours. Hours plus hours have to be equal to hours. So that means if I take X, which is my number of hours traveled on foot, plus the number of hours traveled by boat, it has to come out to 48. However, they don't have to get there in exactly 48 hours. They have to get there before the storm hits. So if they get there in exactly 48 hours, they will be getting there as the storm is hitting, which is okay, because they will be safe. But if they get there in more than 48 hours, they're going to have to travel through the storm, which they don't want to do, which means that it has to be less than or equal to 48. Now, think back to last unit with systems of equations with the Miss Maida example, and hours times miles per hour is going to give you miles. That you guys should know, especially if you're in chemistry right now with all of your canceling and your dimensional analysis. So if we take the number of hours that we travel by foot, which is X, times the 3 miles per hour that they can travel while walking, that will tell us how many miles they can travel if we know how big X is. Likewise, if we take Y, which is the number of hours they travel by boat, times the 12 miles per hour that the boat travels, and we combine those, miles per hour times hours gives us miles, so miles plus miles has to be miles, which is 240. Now, if they reach exactly 240 miles, they'll be at the base camp. But if you remember, once you get to base camp, are you just going to stop moving? No, think about like in terms of if you are tracking your steps. You're going to be constantly moving. So that one has to be greater than or equal to 240. And we have our system of equations. If we wanted to graph it, we could. We are not going to. So what you're going to do now is try this system of linear inequalities. You're going to graph it on this beautiful graph. And also this one. And as always, bring your questions with you to class.